Hey guys, Mr. Schultz here. I'm live from my office. Oh yeah, living the high life. Okay, so hopefully the chapter 4 test wasn't too bad for you. Today we're going to start chapter 5. So if you remember when we started unit. If you remember when we started unit 4, that I said we have about a month of triangles. Well, now we're in the second part of that month. So this unit is still over triangles. We're going to be looking at right triangles this time. And then after unit 5, then we can take a little break from triangles. So let me share my screen with you and we will get started. Okay, so we're going to start off fairly simple today. It's not going to be completely new material. There may be some things that you haven't practiced in a while, but it won't be completely new. So with that being said, we're going to look at simplifying radicals and the Pythagorean theorem. Remember, we've already looked at this once. This is the whole thing that says a squared plus b squared equals c squared. So we'll look at that in more detail. Before we do that though, let's talk about a little history and simplify some radicals because we're going to have a radically awesome time. So the Pythagorean theorem is probably the most famous relationship in all of math. I mean, all you have to hear is a squared plus b, and then you can finish it. A squared plus b squared equals c squared. You may not remember anything else, but you remember that because it's probably the most famous mathematical relationship. And it's named for the Greek mathematician Pythagoras. Who lived in the 6th century BCE. However, this relationship was known way before him. The Babylonians knew it, the Egyptians knew it, the Chinese knew it, but as with all things math, he was the first one to be able to prove it. They knew it existed, but he actually proved it and then said, I proved it, my name goes on it. So yeah, I think that's kind of funny how other people knew it, they just couldn't prove it, so they didn't get to put their name on it. He did. So to simplify, when we do this, sometimes we're going to have to simplify square roots. So to simplify a square root, we need to factor the number under the radical. Now you may be thinking, what's a radical? I mean, I know what radical groups are, but what's a radical? The radical is the square root sign. That's what a radical is. So we need to factor the number under the radical into factors so that one of the factors is a perfect square. Now, this is all fine and dandy, and you can do it this way, but it still tends to confuse some people. So let's look and see what they mean by that, and then I'm going to show y'all a different way. Okay, so here they said we want to do the square root of 27. Okay, fair enough. Well, 27 is equal to 9 times 3. 9 is a perfect square. So once we factor it, then we multiply it here. 9 is a perfect square that's equal to 3. So this becomes 3 square roots of 3. With the 32, we take the square root of 32. Well, that's 16 times 2. So we split it up. 16, the square root of 16 is 4. We're left with 4 square roots of 2. Now, here's the problem with doing it this way. You have to realize those are the factors. I've learned that in Algebra 1, y'all often didn't do it this way. Y'all made a tree. So I'm going to use that method. If you want to do it this way, you can. I'm going to use the tree method because I've kind of figured out that's what most of y'all are familiar with. So what we want to do is figure out what multiplies to give us this number under the radical. So for 75, I'm going to say 3 and 25. Now, once I reach a prime factor, I'm done with that branch. So if I look here at 3, it's 3 prime. Can I multiply anything to get 3 other than 1 times 3? If you say, yeah, 1 times 3, no, just stop. I don't care about 1. If 1's the only thing that goes into it, then you're done. I'm done with 3. So now let's look at 25. What can I multiply to give me 25? 5 and 5. Now, on 5, I'm done because the only thing that multiplies to give me 5 is 1 and 5. So I'm done. Okay, well, we've got to somehow get an answer here. Here's where I tend to find that students can kind of relate to this more. What happens, like, if someone, let's say you have a significant other, what do y'all like to do on Friday nights? And I don't mean other things. Let's keep this appropriate. You may want to go out on a date. So what happens? Couples, oh, hang on here. Couples go out on a date. Singles, well, singles go out and have fun on their own. Now, singles, let's say singles stay home. Couples go out on a date as one unit. Singles stay home. So here's where that's going to come in. This pair of 5s goes out and turns into 1 5. Who's single under the radical? A square root of 3. So the 3 stays, he's single, he stays home. The couple goes out on a date. Okay, let's look at number 2. We have the square root of, so let me back up. This is my answer here. 5 square roots of 3. On number 2, we have the square root of 18. Now, let's see, this one, I'm going to just go with the first thing that pops in my head, 2 and 9. From there, 2, I'm done. 9, though, I can break up to 3 and 3. 3, I'm done. 3, I'm done. Okay, so I'm done there. Now, let's look for any couples. At the ends here, look for couples. Here's a couple. Do we have any singles? The 2. He has to stay home under the radical. Sorry, but he didn't get to go out on a date. Couples come out, and they become 1. Hopefully you're not going to go out on a date and then say, I'm leaving you here. You got to walk home. Well, we're not going to play that game. We're going to be nice. We're going to be hospitable. Even if you can't stand them, at least finish the date and take them home. And then you separate. But right now we're just going on the date. So the 3 goes out on a date, and the 2 is single. They stay home. So 3 square roots of 2. Number 3 can be kind of a long one, so I'm going to do a sideways tree. First one that pops in my head is 2, because I see it's an even number. So what can it be? 2 and 54. And again, I'm going to just, you don't have to do it this way, but I'm just trying to do it to where it's like the first thing that pops in your head. That's what I'm trying to think. You know, I'm looking at 54. Oh, that's even. Okay, fine. 2 and 27. So now we look at 27. Well, 2 can't go into it, but 3 can. And so can 9. So then I'll look at this. 9 is 3 and 3. Now I'm done. I've reached dead ends. So now I need to look for couples here. Well, here's a couple. Here's a couple. Both of them go out on the date. We're having a double date here. And then which one is single? That 3 right there is a single. He has to stay home. So now this is going to give me 2 for my first pair times 3 for my second pair times the square root of who stayed home? That 3. Now I got to simplify this outside. What's 2 times 3? 6. So I'm going to have 6 square roots of 3 as my final answer. Now this is actually the longer way you could have done it, but like I said, I want to just show y'all how even if it's the long way, it can still be done. Number 4, I'm going to do a shorter way. Let's say you look at 48 and you're like, ooh, I know that. 48, that's 4 times 12. Right on. It is 4 times 12. And then like, ooh, I know 12. 12 is 4 times 3. Well, then if you look here, I have a couple. I can break it up, but I don't need to break these up because there are a couple already. So I don't have to go all the way out. It's a couple. He can come out together and we just stop there. And then who's a single? That 3 is single, so he stays home. So this becomes 4 square roots of 3. Okay, 50. Now for 50, you may start out saying, oh, okay, 5 and 10. And then 5, I'm done. 10, what multiplies to give you 10? 5 times 2. Again, 5, I'm done. 2, I'm done. So now I look for couples. There's a couple. Couples go out on the date. Singles stay home. So this couple comes out. We're gonna have a 5 out, and then square root of 2 stays home. Okay, next one, 98. I'm gonna just go with 2. I know it's even. I know 2 can go into it. Other than that, I'm kind of stumped. I just see it's even, so I know I can start with 2. That's what I'm gonna start with. Just start with what you know. You know 2, go with it. 98 divided by 2 is 49. 2, I'm done. Now 49. Let's see, 49 is 7 times 7, which again, 7's prime, so I'm done there. Look for your couples. 7's go out on a date. Single stays home. So they're coming out. They're going on a date. We're going to have 7. And then who stays home? The 2. So 7 square roots of 2. Okay, so there's how you simplify radicals. But now what happens if we have a radical on the bottom? Fractions are not proper if there's a radical in the denominator. So to get the radical out of the denominator, we have to multiply by a special number 1. And I'm going to put 1 in quotes because we're not multiplying by 1, we're multiplying by something else. And also, remember, denominator is our bottom number. Okay, so now using this, let's look at this next set of examples. If you notice, this example, we have a square root of 2 in the bottom. There's a radical in our denominator. So we're not good. We've got to fix it. Now, our special number 1, to get that, you're multiplying by whatever is in the denominator. So the square root of 2 divided by the square root of 2. That's our special number 1. Just the radical over the radical. So what this becomes on top is 12 square roots of 2. And on the bottom, we're just left with a 2. Since we multiplied, now the radical goes away on the bottom. But notice 12 can still be divided by 2. What is 12 divided by 2? 6, and then we're still left with our square roots of 2. Now let's look at the next one. We have 7 divided by the square root of 2. So our special number 1 will be the square root of 2 over the square root of 2. That's our special number 1. So that means on the top up here, we're going to have 7 square roots of 2. On the bottom, we're free from the radical, so just a 2. Now you have to look, can you simplify 7 over 2? No, you cannot simplify it, so we're done with this problem. It just stays like that. Okay, on to the next one. Our special number 1 would be the square root of 3 over the square root of 3. And you're like, why are you doing 3 this time? I don't get why you're doing 3. You did 2 first. Well, I did 3 because that's what's in my bottom. Whatever is in the bottom, that tells you what your special number 1 is. Okay, so continuing with the process, we have 5 times the square root of 3. All over 3. I'm free from the radical on the bottom. I can't divide 5 by 3, so I'm done. Now for number 10, square root of 3 is on the bottom. So I'm going to do the square root of 3 over the square root of 3, which will give me 9 square roots of 3 over 3. Now, if I look at this, though, can I do 9 divided by 3? Yes. 9 divided by 3 is 3 square roots of 3. I'm done there. Okay, next one. The next topic is our Pythagorean Theorem, the one we all know and love. So Here, our C will always be across from our right angle. This will always be our hypotenuse. A and B, the ones that touch the right angle, are the legs. So the Pythagorean theorem says C squared equals A squared plus B squared. We don't know it that way. We usually say A squared plus B squared equals C squared. That's how we're used to saying it. So let's actually use this to help us. Before we do that, though, we need to talk about something that's called a Pythagorean triple. So a Pythagorean triple is a set of non-zero whole numbers where A squared plus B squared equals C squared. So these are called a Pythagorean triple. There's no decimals in a Pythagorean triple. There's no square roots in a Pythagorean triple. They're all whole numbers. So I'm going to make note of that. All whole numbers. And they have to satisfy this equation here. Okay, let's look at these next examples. So they ask us to find the value of x. Well, notice x is our C here. It's our hypotenuse because it's across from the right angle. So we can say 3 squared plus 4 squared equals C squared. 3 squared is 9. 4 squared is 16 equals C squared. So then I have to do 9 plus 16 to get 25. Take the square root of this. 5 equals C. Which I'm using C. What should I actually be using? Not C, but all of these C's should be X's. That's my bad. So what do we know? X is equal to 5. Now this one, since X is 5, notice we have 3 whole numbers here. So that means we have a Pythagorean triple. And this triangle is kind of infamous. It's just a 3, 4, 5 right triangle. I mean, you don't have to know that. It's just an infamous triangle. If your legs are 3 and 4, your hypotenuse is 5. 3, 4, 5. Okay, next one. They ask us to find the value of x and round to the nearest tenth. So let's see. This x is my hypotenuse. So it's going to be my big side. So that means I have to do 15 squared plus 9 squared equals x squared. 15 squared is 225. 9 squared is 81. If I add these together, I'll get 306 equals x squared. Now I'll take the square root of it. And when I take the square root on my calculator here, it will tell me that 17.49, it gives me 17.49285568. That's what it says x is equal to. Now it tells me to round to the nearest tenth. So I only want this digit, which means I need to look at my 9. So my 9 tells my 4 to go up. Remember, 4 or less, let it rest. 5 or more, raise the score. We have a 9 right here. So we need to raise the score. So x equals 17.5. That's the nearest tenth. And we're done. Okay, next one. Find the value of x. Simplify the radical. If you give me this answer as a decimal, I'm taking points off. It doesn't tell you to do it that way. We have to simplify the radical like we did at the beginning of the notes. So if we look, make sure we know what side the x is. It's our c. So we'll say 2 squared plus 2 squared equals x squared. 2 squared is 4 plus 4 equals x squared. 4 plus 4 is 8. So I need to take the square root of that. Now here's where the simplify the radical comes in. I have to simplify the square root of 8. So that's where we do like we did in the very beginning. What multiplies to give me 8? 2 and 4. What multiplies to give me 4? 2 and 2. So couples go out. Singles stay home. Couples go out. Singles stay home. So I'm going to have x equals 2, because this couple went out, square roots of 2. There's our answer. So that's the Pythagorean theorem. Now we're going to extend that just a little bit. So we know for a right triangle that the Pythagorean theorem says a squared plus b squared equals c squared. We know that. That tells us it's a right triangle. Now, what if we have an obtuse triangle? We will know this because a squared plus b squared will be less than c squared. So I'm going to mark this out because I don't really want us using this way. Mark this out. I don't want us using it written in that way. So it's obtuse if a squared plus b squared is less than c squared. Mark this out. I don't want us using it this way. It's acute if a squared plus b squared is greater than c squared. That tells us it's acute. Okay, so on these, first we have to say whether it can be a triangle or not, just like we did in Unit 4. If it can be, we have to say what kind. And we have to use the method we just talked about. So let's go through on each of these first and figure out if it can be a triangle. So remember, the sum of the two smallest sides needs to be greater than the largest side. So if I look at number 5, 7 plus 12 gives you what? Because these are my two smallest. Gives us 19. How does that compare to 16? It's greater than. So can this be a triangle? Yes. That's our first step. Okay, I'm going to just do the triangles first, see if they can be a triangle first, and then we'll go back and do the other part. So let's look at number 6. My smallest two sides are 11 and 18. So 11 plus 18 is equal to 29. How does this compare to 34? It's less than. Can this be a triangle? No. Next one. 8 plus 11 is equal to 19. How does that compare to 13? It's greater than. Can this be a triangle? Yes. And then the last one, 5 plus 12 is equal to 17. How does that compare to 13? It's greater than. So can this be a triangle? Yes. Now that's just the first part of the question. That was part 1. Now we need to do part 2. Classify the triangle as acute, obtuse, or right. So what I'm going to have to do here is I'm going to have to see how does 7 squared plus 12 squared compare to 16 squared. So 7 squared plus 12 squared is 193. 16 squared is 256. So how do these compare? Which one is bigger? The 256 is bigger. So which one has c squared being bigger up here? this middle one, which means it is obtuse. C squared is bigger, so we're obtuse. This tells us over here that we are obtuse. Now, number 6, we can't be a triangle, so we're done on that one. We can't go further. We're done. Number 7, I do have a triangle, so I need to go further. 8 squared plus 11 squared. How does that compare to 13 squared? Well, let's see. What is 8 squared plus 11 squared? It's 185. What is 13 squared? 169. Which one's bigger? 185 is bigger. So which one has a squared plus b squared being the bigger number? This one, the acute triangle. So we are acute right here. Okay, on the last one, we have a triangle. So we have to compare now. 5 squared plus 12 squared. And we have to see how it compares to 13 squared. Well, let's see, what is 5 squared plus 12 squared? 169. What's 13 squared? 169. So how do these two numbers compare? They're equal. So which one says they're equal? And again, the key here that we want to look at are the signs right here. Which one says they're equal? The right triangle. So this one is right. Okay, so that's the notes for the first unit, or the first day of Unit 5. Stay tuned for the Unit 5 Day 1 guided practice.